Welcome, ladies and gentlemen. What I'd like to do is kind of go over the basics of what you need to know to be able to solve a system of two linear equations by using elimination. So the first thing is understanding what exactly is a system. Now, basically, we've worked on solving linear equations, but a system is going to be anytime we're solving an equation when we have two or more equations. But basically for this course, we're only going to be doing with two equations in two variables. So at least understanding what exactly a system is and what is our purpose. And that kind of goes back to when we're solving by elimination, that is kind of one of our algebraic approaches. But I think it's very important to also know what exactly are the solutions, how to identify the solutions, and also how to identify the system, as far as being independent, dependent, or having consistent or inconsistent solutions in your system. And basically, we look at that from the graph. When we have one solution, that's when our two lines intersect, when we graph them. If there's no solution, that means we have parallel lines. And if there's infinite many, that means we have the exact same line, or one line on top of the other one, creating the exact same linear line. The next thing, at least for the algebraic approach to elimination, is one understanding what is the idea of a multiplier or equivalent equations. So for instance, if I gave you the equation 3x equals 10, and I say, well, if I wanted to prove, say, equivalent equation, if I multiply by a multiplier of 2, I get 6x equals 20. Well, 3x equals 10 is the equal to 6x equals 20. And the same thing, if I did 3x plus 1 equals 10, and again, I multiplied by another multiplier, let's say negative 2, well, I'm producing equivalent equations. These two equations are equivalent to each other. They're just being multiplied by a multiplier, but the solution is not going to change. So that is very important in understanding what is a multiplier as well as what are equivalent equations. And then the last thing is how to add and subtract equations. When we're going to be using elimination, we're going to be adding and subtracting equations. And to understand that, when I add and subtract an equation, and let's say I have 5x plus 1 equals 10, and negative 5x, let's do y actually, plus y equals 10. When I add these up, 5x minus 5 is 0x, right? Plus 2y equals 20. So we add our equations up. Notice that 0 times x, though, is now just 0. And 0 plus 2y is just 2y equals 20, where now we can solve for y. And the last thing, I didn't even write that in there, is substitution. Remember, substitution, which is basically like evaluating basic things. So if I find the value of y, and let's say y is equal to 10, and I have an equation 5x minus y equals 15. Well, if I want to solve for, if I know y equals 10, and here's an equation, I can plug 10 in for y. So I'm left with 5x minus 10 equals 15. Then I just solve your equation, which was another one. Solve equation, which I didn't even think about. Solve equation, so I have 5x is equal to 25, divide by 5, divide by 5, x equals 5. So when solving a system using elimination, here's kind of like your basic understanding. And then here's some of your algebraic processes that you're going to need to know when completing this course. Thanks.